Hello my dear students, today let us go for one more topic of electrochemistry, relationship between degree of dissociation, molar conductivity and problems based on these concepts. Without any delay, let us go for it. Myself Jairaj Hegde. Let us try to understand what is degree of dissociation alpha. As we have already learned it in first year chemical equilibrium topic, degree of dissociation. Actually, the degree of dissociation stands for the fraction of molecules dissociated into ions. The fraction of a species dissociated into ions per mole. So 1 mole of, if I have taken 1 mole of solute, how much fraction it has undergone dissociation, that's what we call it as degree of dissociation alpha. And we have fixed relationship between degree of dissociation alpha and molar conductivity as alpha is equal to lambda m by lambda m naught. This is for weak electrolyte, because for strong electrolyte degree of dissociation is 1. It's always unity because it undergoes complete ionization, whereas for weak electrolyte it is less than 1. So that's why we can get it through the ratio of molar conductivity of solute at any concentration by limiting molar conductivity or molar conductivity at infinite dilution. Here lambda m is nothing but molar conductivity of an electrolytic solution at any concentration C, and lambda m naught is limiting molar conductivity or molar conductivity at infinite dilution. As we already know, alpha is degree of dissociation. For weak electrolytes like CH3COOH or NH4OH, as it is a weak electrolyte because it is weak acid, NH4OH is a weak electrolyte because it's a weak base. We know from the last chemical equilibrium topic, we already know if it is a AB kind of salt which undergoes dissociation to form A plus and B minus, then Ka will be equal to C alpha square divided by 1 minus alpha. So if I substitute alpha as lambda m by lambda m naught, so C into alpha square is nothing but lambda m square divided by lambda m naught square into 1 minus lambda m by lambda m naught. So if I solve it, simplify it, if I multiply this lambda m naught square over here, it will become what? Lambda m naught minus lambda m divided by lambda m naught. I can cancel lambda m naught square and lambda m naught. So it will become Ka is equal to C lambda m square divided by lambda m naught into lambda m naught minus lambda. So C lambda m naught square by lambda m naught into C lambda m naught minus lambda. We can, however, we can remember this equation, it's not a problem, or else we can derive it at the individual point of time by knowing the formula by calculating alpha directly. We can calculate alpha directly by knowing lambda m by lambda m naught, and we can directly substitute that in C alpha square divided by 1 minus alpha. Both processes are easy, both steps we can go for it. Let us try to go for problems. Let us go for question number 1. The conductivity of 0.00128 mole per liter or molar acetic acid is 4.95 into 10 per minus 5 Simon per centimeter. They have given specific conductance or conductivity for this much of concentration. Calculate the dissociation constant if the molar conductivity at infinite dilution. They have given limiting molar conductivity or molar conductivity at infinite dilution. Lambda m naught is given. It is 390.5 Simon centimeter square per mole. Lambda m naught is already given. They have asked us for the calculation of dissociation constant of a weak acid Ka. They have asked us Ka, dissociation constant of weak acid, and they have given specific conductance or the conductivity, and the concentration is given. Specific conductance or conductivity is given over here, and the concentration is given. And with using these two, we should have to calculate a lambda m. Initially, we should have to calculate lambda m, then we can calculate alpha and Ka. So let us go for it. Concentration is given. The concentration is 1.02 into 10 power minus 3 mole per liter. Lambda m naught is given 390.5 Simon centimeter square per mole, and the specific conductance or conductivity is given. It is 4.95 into 10 power minus 5, and they have asked us to calculate the degree, the dissociation constant Ka. It is asked. So we know the relationship. Ka is equal to C lambda m square divided by lambda m naught into lambda m naught minus lambda. Initially, we should have to calculate lambda m, as we don't know the lambda m. Using the value of kappa and concentration, we can calculate the lambda m value, and the lambda m value, as they have given kappa in terms of centimeter, we should have to use the formula lambda m is equal to kappa into 1000 divided by C. So then we will get the value of lambda m as Simon centimeter square per mole, as they have given kappa as Simon per centimeter. So that's why we should have to substitute kappa into 1000 by C. Kappa we know 4.95 into 10 power minus 5, and 1000 is nothing but 10 power 3, and the concentration is 1.028 into 10 power minus 3. So if I try to solve this, it will come as 48.15 Simon centimeter square per mole. So now we know lambda m naught, we know lambda m we have found out. So based on lambda m naught and lambda m, we can either calculate alpha directly, and after calculating alpha, we can go for the substitution of 1 minus C alpha square divided by 1 minus alpha. That also can be done. Or if we can remember the formula, directly we can go for Ka is equal to C lambda m square divided by lambda m naught into lambda m naught minus lambda m. We can either go for this formula as well. So if we substitute the values, 1.028 into 10 power minus 3 into 48.15 into 48.15, because here we should have to take lambda m square, and it is 48.15 the square, divided by lambda m naught is 390.5 minus 390.5 minus 48.15. If I simplify it, I will get the answer as 1.78 into 10 power minus 5 is the degree of, it is a dissociation constant of weak acid, acetic acid, which is given. The Ka will be equal to 1.78 into 10 power minus 5. Even we can do in other method also, as I have told you earlier. If we cannot remember this huge formula, it is very easy to calculate alpha by lambda m naught. If we can calculate alpha directly, we can substitute that the value of alpha as C alpha square divided by 1 minus alpha. Even we can do the same. Both will yield the same answer. That's for today. Thank you for watching. Thank you for support. Like, share and subscribe.